Hello everyone. Welcome to the Mechatronics class. I am your instructor, Ma Qinjie. In previous lessons, we covered the applications of robotic arms and conveyor belts. In this lesson, we will combine both to create a simple production line scenario, integrating our knowledge. We will cover the following topics. Learning objectives. 1. Understand the components and working principles of a simple handling production line. Learn to create motion units, joints, sensors, actuators, and grippers. Now, let's look at the specific operational steps. Now we will demonstrate the specific operational steps. First, we create the rigid bodies. Select the moving components that were just mentioned and create them as rigid bodies. Choose the material, created as a rigid body. And click Apply to complete the material rigid body creation. Next, select the telescopic rod, created as a rigid body. Click Apply and complete the telescopic rod rigid body creation. Select the slider, created as a rigid body. Click Apply and finish creating the slider rigid body. Then, select the rotating rod, created as a rigid body. Click Apply and complete the rotating rod rigid body creation. Finally, select the turntable and the sensor on it, create them as rigid bodies. Click OK, and finish creating the 5 moving components as rigid bodies. Next, we analyze whether the moving rigid bodies interact with other objects. If there is any contact, we need to set them as collision bodies. Upon analysis, we see that the material will come into contact with the conveyor belt and move forward. Therefore, we need to set the material as a collision body. Choose Mesh as the collision shape. And click OK to complete the creation of the material collision body. We must also set the conveyor surface as a collision body. and click OK. Additionally, in this simulation, there is another part that must be set as a collision body, which is the material collection slots on the turntable. Select collision body, and one by one, set these 6 material collection slots as collision bodies. Choose Mesh as the collision shape. And complete the creation of the 6 material collection slots as collision bodies. Next, we create the object source for the material. Click OK to complete the object source creation. Now, we move on to creating the basic joints. In basic joints, the main focus is on the sliding joint between the telescopic rod and the slider. Select sliding joint, choose the telescopic rod as the connecting body and the slider as the base body. Set the vector to point in the horizontal direction. Click Apply, and complete the creation of the sliding joint between the telescopic rod and the slider. The second sliding joint involves the relative sliding motion between the slider and the rotating rod. The vector here should be set upward. Click Apply to finish creating the second sliding joint. Next, we create 2 rotating joints, which involve the rotation of the rotating rod. First, choose hinge joint. Select the rotating rod as the connecting body, and set the vector to the cylindrical outer surface at the base of the rod. Click Apply to complete the creation of the hinge joint for the rotating rod. The second hinge joint is for the rotational movement of the turntable. Select the turntable as the connecting body, and set the direction vector pointing upward. For the anchor point, choose the center of the turntable. Click OK to complete the creation of the 2 hinge joints. Next, we create collision sensors for the material slots on the turntable. Set these as collision sensors. Select collision sensor and create 6 collision sensors for the 6 material slots. For the first one, select cylinder as the collision shape. Set the height to 1 and the radius to 10. Specify the coordinate system and name it CS1-0 for the center at the 0-degree direction. Click OK. Repeat this process for the remaining 5 material sensors. Click OK to finish creating all 6 material sensors.